Let me start with my quick introduction, and then we will proceed further. Further, that what all sort of topics we are going to cover during this training. So, my name is Saurabh Yadav, and I'll be taking your F5 BIG-IP DNS training. Earlier, it used to be known as GTM, right? Global Traffic Manager, but now we call it DNS, domain name server, or you call it domain name system, whatever you would like to call it. But it's a DNS module that we are going to cover throughout this training. We will be able to get this completed within 3 weekends, which means these 6 sessions. That would be sufficient for us to cover all the content of this DNS module. So if we talk about the content, that which all topics we are going to cover during this training. So let me just quickly open up the content here, and then you can ask questions in case if needed around that. Basically, let me just pull it away. Okay, if you look at here, right, let me put it into the full screen mode. If you look at here, so it has got like multiple chapters in this training. So we're going to start with chapter 1, where I'll cover a little about the setting up the big IP system, so that you know that how we can set up the big IP systems. Although you are already familiar with that, like that's my expectation. Why? Because all of you already went through the LTM training, and the big IP is common. That's a good thing, right? The device is common, right? Big IP is big IP. No matter if you are going to utilize it as a LTM or maybe DNS, or maybe you are going to utilize it as an ASM, which is WAF, or maybe you are utilizing it as APM, right? So it does not really matter in F5 technology that what sort of module you are going to activate on your device, but the backend device is going to be same. Even the operating system is same. So that's a good thing about the F5 technology. So the big IP is same as like which you had during your LTM training, or in case if someone did not go through the training, at least they have an idea that how LTM works and what big IP is all about, right? So the big IP is going to be same as LTM. The TMOS operating system is also going to be same as before, and even making basic configurations such as creating VLAN, allocating IP addresses, creating Ether channel, adding routes, taking backups, restoring the backup. All those sort of things that you learned before is also going to be same here in Big IP DNS training, right? Although, like I will be setting up the big IP, because setting up big IP is will be required in our lab, right? Because that's not pre-configured. So we will be setting up the big IPs, right? Especially the DNS module, especially the DNS, right? Like that big IP where we are going to provision the DNS. However, the LTMs are already provisioned in our lab. Therefore, you would not be needing to provision anything on LTMs. Although, whenever you have access to the labs and you start working on the DNS module, you guys would be needing to set up the LTM as well along with the DNS. Then second would be the introduction to the DNS. That's where I'm going to explain that how DNS works, what is the use of DNS, right? So that's chapter 2. And 3 will be like how we can accelerate the performance of DNS by leveraging the big IP DNS, how we can utilize the big IP DNS. So that's chapter 3. Then chapter 4 is going to be explain you the intelligence, or I would say intelligent DNS resolution. And that's where you would see the actual use cases of the big IP DNS, because before it, it's like even you are using some older DNS mechanisms, right? So like accelerating DNS, although like it will help us to accelerate the performance of the DNS resolution, but the actual impact of big IP DNS onto DNS resolution would be seen during chapter 4. So that's where you learn about the intelligent DNS resolution, right? And that's why, I mean, this chapter 4 is all about like, it will explain you that why do we actually use the big IP DNSs for the name resolution or for the DNS resolutions. So chapter 4 is going to be really important for you. And then chapter 5 is also like, obviously, if you talk about some of the load balancing algorithms that big IP DNS can utilize. So some of the load balancing algorithms would be needing you to configure some props and metrics so that it can, like the big IP DNS can collect all the needed resources to perform said load balancing algorithm, because sometimes you would be wanting your big IP to perform load balancing, such as like based on the least time, I would say, right? Or TTL, time to live, right? So for example, like you want to provide an IP address in the DNS response, which is really performing well at this point of time, from where you can access your application with fast speed or in a faster way. So that's where the LDNS props and metrics would be needing to be configured. Then you have got the load balancing algorithms. As I told you, that it has got so many different options. In most cases, we do not really modify them, and in most cases, we have got some common load balancing methods. Like by default, it's round robin, which is similar to like what we had in LTMs. So even in LTMs, we had round robin as a default load balancing algorithm, and that's what we are going to have here in DNS, right? So the load balancing algorithm, the default one is common, but yeah, we have got some differences as well. So there are like some sort of like a static persist is something that you never heard before, or maybe global availability is something which you never heard before, right? So yeah, there are some new load balancing algorithms that are mainly developed by F5 for DNS module only, and that's what you are going to cover over here, right? And also you have got some dynamic load balancing methods. So you have got basically static and dynamic both. So it will be depending upon the requirements for your application, right? For your customer, that which algorithm should be selected for uh, for load balancing purposes. And then we have got the monitoring. Monitoring is all same as before, so there is nothing new. It's same as like LTM. So you don't really have to worry about the monitoring, because this chapter is all about what you learned in LTM, right? LTM training. And if you have some experience over LTM, then creating monitors would be, like easier for you. And then advanced big IP DNS topics, where we talk about the DNS SAC, or maybe, we can also perform some topology based load balancing, right? So when I say topology, which means that you can select some sort of um, like you can select some sort of continents, or you can match your incoming requests based on continents, or maybe a country, or maybe based on the source IPs. And then you can you can specify some sort of specific pools, that okay, I want to use this pool of DNS servers, I would say, right? This pool of DNS servers, in case if the request is coming from this region, this country or continent, or maybe containing the source IP address. So that's basically called the topology based load balancing, and that's what you're going to configure over there, right? So that's that. And then that's it, right? So these all are the chapters that we're gonna work on, are going to cover throughout this training. So in total, we're gonna cover like 8 chapters, and we're gonna start with chapter 1. But before we get started with chapter 1, I would like to have a quick discussion. I would like to have a quick discussion around the certification of this big IP DNS module. So if we talk about the certification, if you want to attempt your exam, right, for big IP DNS certification, so you should be having that idea that, okay, which certification you can call it here. So if you go to f5.com, so you have multiple tabs at top, like solutions, products, partner, resources. So if you go to like resources, and then if you go to education, under education, then you should have professional certification. So just click on professional certification, and that's where you would get the certification path. There is a chart. If you scroll down a little, so there is a chart that you would see. So as per this chart, basically the big IP DNS comes under 302. So under CTS, Certified Technical Specialist, this is the exam that you can take, 302. But there is a condition. The condition would be, you can't really take this 302 directly if you have not gone through 101 and 201. So it's important for you to go through 101 and 201 before you take this 302 exam, right? So you take 302 exam, and then, I mean, before that, you must make sure that you are already past 101 and 201, right? Then after, you can take this 302. So 302 has got dependency over 201, and 201 has got dependency over 101. So you can't bypass them. So if you say that, hey, no, I don't want to take on 101 or 201, but I want to take on 302 directly, no, that's not going to be possible in case of the F5, like as per the F5, the F5 certification hierarchy. So based on the F5 certification hierarchy, it is important for you to go through these steps: 101, 201, and then only you can take like 301 or 302 or 303 or 304. But that's the exam that you would take for big IP DNS module. So you can see that here, 302. So that's the exam. And then also you can look at the exam study material, which can give you kind of like blueprint, right? That, okay, these are the topics that you should focus on before taking the exam. So at least you can go through that, right? So now, if you look at here, especially for the DNS, right? So there you go, right? So 302. Let me just take a look at the. So that contains like this PDF which I have downloaded here. Like it explains you like which type of questions you're gonna get during your exam, right? So MQC based questions, that's what you gonna get during your exam. And also this is the blueprint for taking your GTM exam. So previously we call it GTM, but now we call it DNS. So remember that F5 has already renamed the GTM with the DNS. So sometimes you would see that commands in commands we are still using GTM keyword, not DNS, right? So don't get confused. Earlier we used to call it GTM. And even lots of commands are still based on that keyword GTM only. So don't get confused with that. So GTM and DNS is same thing. GTM stands for Global Traffic Manager, and DNS is domain name server. Even GTM was also working as a DNS server. I will explain you that why they renamed GTM with DNS, right? I will explain that in a moment. But you can see that prerequisite for it is the F5CA, which is certified administrator, which means you must take 101 and 201 before taking 302. And these are the exam topics. So you should be knowing about the DNS, right? So like what are the hierarchy, like root domain, and then, I mean, there is a tree, right? That even I'm going to explain to you, right? So about the DNS, right? So you need to know that, okay, what are the root domains? Who are managing them? Right? And then we have got some sort of child domains and who are managing them, right? And then evaluate existing DNS environment for big IP DNS solution, right? So you need to look at the existing environment, and then you would have to see that how you can perform the deployment for big IP DNS solution, right? So then you have got determine for performance requirements for a big IP DNS resolution, right? And then TMOS sync groups. It's about establishing, it's kind of high availability for the big IP DNS. Remember that we do not configure, ideally, we do not configure the failover for big IP DNS, like unlike LTM, right? Because in LTM, we saw that at each site we had like at least two big IPs working in active standby mode. We don't do that in case of big IP DNS, right? We don't configure the big IPs in that way. If we have got like two data centers, then each data center would have at least one big IP DNS, and both of them will be in a single sync group, and both of them will be working as a DNS server at same time. And you can work or you can have them configured in any cast way, like both big IP DNS can be reachable through a single IP addresses, right? Hosted in both data centers. And as soon as you create entry on one big IP DNS, the entry would get created on the other big IP DNS if they are in a single sync group. So it's kind of high availability, but not the failover. Then the GSLB, like what are the different options for the GSLB? Basically, that's the intelligent DNS resolution, right? That which all options you get when it comes to the intelligent DNS resolution, right? And then identify configuration options for non-GSLB DNS component. It's like basically it's all about um, improving the performance of the existing DNS servers by leveraging the big IP DNS. And then you have got necessary network environment for GSLB operations, right? Determine when and how employ the appropriate. I mean, you can go through it. I don't really have to read each and every line here, right? So they have already given you this blueprint, and based on this blueprint, you're gonna cover all the topics here during this training, right? So exam cost is $180 plus 28% GST. and the duration of this exam would be 90 minutes, and the passing score would be 245 out of 350. That's the maximum score that you can get. So minimum score would be 245, right? And then you're gonna get the 80 questions which you have to solve in 90 minutes. So it's little. So time management is really important, especially in this type of exam, right? So that is really important. And out of 80 questions, 70 questions would have the scored, but other 10 questions would be like the pilot beta items. So that's that. Okay, all right. So that's about the F5 certification. I'm gonna close this out, and yeah, let's talk about that why F5 renamed this product from GTM to.
Sir, just one quick question.
Mhm.
Currently, we can give this kind of exam from the home itself, or like we need to visit the centers?
You need to visit the center. F5 is not providing that facility as of today, right?
Okay.
That you can take your exam from home.
Okay. Thanks.
So there is a center in Magarpatta, if I'm not wrong, right? So if you want to take the exam, you can go to Magarpatta, at least in Pune, that I am aware of.
Mhm.
So and then you can take the exam.
Okay.
So in each city, like they have got 2, 3 centers, because it's not like each and every prometric center would allow you to take on the F5 exam. No, the F5 exam can be conducted by Pearson own centers.
Yep.
So if it is a Pearson owned center, then only you can take on the exam. So it's like similar to like GMAT, GRE kind of thing.
Okay.
Okay. So now let's talk about the F5 DNS. Why have they changed this name? Earlier it was GTM, Global Traffic Manager, and now they made it like not now. It's been, I believe that it's been more than a year now, right? Or I would say it's been 2 years now when they renamed GTM with DNS. Okay, let me tell you. See, even if it was a Global Traffic Manager, this module basically works as a DNS server. Let me tell you. In nutshell, it works as a DNS server, right? So if it was a DNS server, then don't you think that it was conflicting as its name, GTM in, you know, GTM specifies like global traffic manager, and at the end of the day, it's working as a DNS server, right? Because it has always been a DNS server, right? You can have DNS servers hosted on Microsoft server module, right? I mean, like 2003, 2000, whatever, 5 or 9, 13. I don't remember exactly their names, but the Windows server can also be configured as a DNS server. So why, I don't know, like why initially or in beginning F5 kept it GTM Global Traffic Manager, but then later they modified it, and now yes, as its operation, or I would say the function of the Big IP DNS is to work as a DNS server. So now F5 DNS module, like this name is more relevant than the before, because earlier it was GTM Global Traffic Manager, right? It was not a relevant name, right, as per its functionality, right? So the function, the primary function of the F5 DNS is to provide the DNS services, right? So it is acting as a DNS server basically for the end user machines. If it is acting as a DNS server, then why do we call it GTM? Why don't we call it DNS then? Why should not we call it DNS, right? So that's why F5 renamed this GTM with DNS, because then later on F5, realized that if it is working as a DNS server, then why don't we put the name as DNS, right? So later on, F5 realized that okay, it should be DNS itself because it is acting as a DNS server. So yes, that's how they renamed the F5 GTM module to F5 DNS. But the command syntax is still same, right? So you would see, and then you will say, well, what is this, right? Because the GTM is still out there, right? Even though at top, at higher level, they have renamed GTM with the DNS. That's okay, but at syntax level, in like when you start working on the big IP using CLI, you would see that still we are using the GTM keyword, right? We still don't have the DNS keyword over there, right? So, I mean, that's annoying, but that's what it is, right? So you would still use that GTM keyword, but don't worry, right? At least now you know that GTM and DNS is the same thing, and it's all about the DNS server. So remember that big F5 DNS or F5 GTM is going to work as a DNS server. It's all about the DNS server. Let me tell you, all F5 DNS would provide you is DNS services. And you know that what are the DNS services, right? DNS would always help you to translate your names into an IP addresses. Like whenever you access the object using its name, then the name would get translated back into their respective IP addresses, because the application servers, like whenever you access any application, let's say you are accessing facebook.com using your browser, or you're accessing google.com, right? In backend, the all application servers have got an IP address. So someone needs to translate that name into an IP address. In beginning, what we did, like when internet came into the picture. So basically, if you talk about the Windows file, let me tell you one thing here. So Windows operating system, right? So Windows OS has got a file on your machine, like on each and every one machine, which is called host file, right? So you can create entries in host file, and you can say that, okay, www.google.com has got this IP address, www.facebook.com has got this IP address. So then your machine would be able to perform resolution using its local host file, right? But then you need to update that host file locally on each and every machine. But think about that, how many machines you have got nowadays. Mostly all of the devices are now IoT devices, including your refrigerators, your washing machines, your coffee machines, and etc., etc. Not only just laptops and desktops, right? So, I mean, it is really difficult to update the host file for the purpose of name resolution. And why we had the names instead of IP addresses. See, I must have given you the IP address of the google.com, facebook.com, and just imagine that you don't know their names. All you know about them is just their IP addresses. So Google has told you that, hey, using this IP address, you can access the application, right? And then Facebook gave you same, right? And all the application owners, they gave you they all gave you the IP addresses. Now you tell me, all of you tell me that, will it be really easier for you to will it be easier for you to remember their names or IP addresses? So if, as a human being, right, obviously, for us, memorizing names is really easier, is really easier as compared to the um, memorizing the IP addresses or the numbers, right? So for us, memorizing names is so easier than the numbers, and that's why in the internet the concept of the name was introduced, right? That we will give you the name, and then you access the applications using their names. And that's what we do as of today, right? So whenever we access an application, we always access the application using their names. We are not accessing the applications using their IP addresses, right? So we are always using some sort of names like facebook.com, or maybe google.com, microsoft.com, etc., etc., right? But in backend, you can't really access those services using their names, right? At the end of the day, the application is hosted on sort of server, right? All of you should be aware with that application is running on sort of server, and that server can be reachable through the IP addresses only, because all we have got is IP routing between a source and destination, right? So even the internet providers can switch data based on the IP packets. So when I say IP packet, which means the packet should have source and destination IP, right? So the devices are always going to perform destination based routing, right? The devices are always going to perform destination based routing, which means that the IP header should contain the source and destination IP both. And whenever an IP packet is received by the routers or layer 3 switches or by the firewalls, they will look at the destination IP, right, and will perform the packet forwarding accordingly, right? But the problem is that how do we get that IP address, right? We know the source IP address, right? Because let's say I'm trying to access the application from my local machine. So and I know that what is the IP address of my local machine. So my local machine is aware that what the source IP address is. But my local machine doesn't know about the destination IP address. And that's where, but I know the name, right? Let's say I was trying to access google.com, right? So my machine knows that, okay, I'm trying to reach out to the google.com, and that's where it was needed for a machine to resolve destination name, into an IP address, right? And that could be done using various methods, like obviously we could use the host file, but then updating host file on all user machine across the globe, I mean, that's technically is impossible, I would say. right? Technically it is impossible because every day new domains are getting registered, right? So I mean, how Microsoft would update each and every Windows operating system then, because this is something that has to be configured at the Windows the operating system level, right? So Microsoft will have to update the host file every day then, or maybe in every couple of hours, right? I mean, that's insane, right? So I mean, this solution, it can work for your internal applications maybe, and using some sort of group policies or GPOs, you can push out that host file locally. You can tell each and every system that, hey, if you are accessing this application, the internal application, then this is the IP address, so that you don't need any internal DNS server to be configured. But apart from that, I mean, I don't think that there is any other use case of the internal host file for the operating systems, right? And remember that this host file concept is not applicable only for Windows operating system. It is equally applicable for the Linux operating system as well. The host file has been there always, right? I mean, even if you talk about the Android, I'm not sure. I never did that. I never tried that. But in my opinion, even the Android should have this host file, right? That's that. All right. So point is that host file could be utilized, right? Your Windows operating system, I mean, mostly all of the operating systems have got this concept of the host file. Host file could be updated, and we could tell a cell phone or maybe a laptop, desktop, iPads or whatever, right? So we could go to those devices and we could update their host file, but as I said, technically impossible, right? How many sites you have got, how many entries you would create in the host file, right? You have got like millions of domains, right? So if you have got millions of domain, then how are you going to create millions of entries here in host file? So that's not going to be possible. And even if you make it possible technically, right? I mean, let's say you used some sort of mechanism to update the host file, then the problem will still, I mean, some problems will still remain exist. How? For example, if someone changed the IP address of the application server, now you need to change that IP address at the host file level. Now remember or imagine that how many users globally you have got where that those updates needs to take place. I mean, that's why I said that, okay, it is going to be possible, right? So we don't use that actually. And that's where the DNS came into the picture, the domain name system or domain name server. So first you have to set up a DNS server. And on this DNS server, you have to create a sort of directory in which you will have to specify, okay, this name has got this IP address. This name has got this IP address. So that directory has to be created on DNS server. Now, if there is a user machine, right, that user machine will always go to, like, if you were trying to access any application like facebook.com on your user machine. So that user machine must go to the DNS server, right? And that DNS server must respond back, hey, this is the IP address of against this google.com. And now when we talk about the DNS server, because we have to talk about the hierarchy of the DNS server, because if there is no hierarchy, then obviously we will end up with kind of same solution that we just spoke about. Like we had a concept um, of the host file, right? Because see, if all the DNS servers are going to create those entries, then it's kind of similar to the host file. The only difference would be like host file is available on each and every user machine, whereas the DNS servers will be kind of centralized system. Like one organization would have like one DNS server, or maybe they will be using service providers DNS server. Because when you talk about the DNS server, there are so many DNS server providers, right? So there are some freely available as well, not some, a lot, right? So if you talk about the Google 8.8.8, that is a DNS server, right? That's a DNS server IP address, and that's free to use. Anyone can use that. 1.1.1, 4.2.2.2, right? These all are the global DNS servers. So 8.8.8 is provided by, I believe, Google, and 1.1.1 is provided by Amazon, and 4.2.2 is also, I believe, provided by the Google, right? And also your service providers, like in India, if you are here, then Airtel, and or maybe the BSNL or Tata, right? These all providers are also having their own DNS servers, right? So you can utilize them. So it's not always necessary that you will be depending upon Google or AWS, right? No, you can also leverage your provider's DNS server. So all the providers here in India, not India, across the globe, right? All the service providers or internet service providers, whether it is AT&T, Orange Business Services, or maybe the British Telecom or T Systems or Sprint or whatever name you take, right? The Deutsche Telecom, whatever, right? So these all service providers must have got their own DNS servers, and they can provide those details to their customers, and customers can start using their DNS servers. But at the end of the day, like DNS servers should have that direct kind of directory where the names and their corresponding IP addresses, right? So those entries must be created on the DNS server. So whenever a DNS, let's say your user machine, right, wanted to connect with an application called facebook.com. So first it will check its local cache if it has got an IP DNS cache I'm talking about basically. So first it will check its local DNS cache if it has got the IP address of the facebook.com in its local cache. If not, then it will send a DNS request to the DNS server, right? So this DNS server would get a request for facebook.com. Now this server is going to check its local cache first if it has got the IP address of the facebook.com in its local cache. If yes, it will provide the response back based on that cache, right? If not, then it will check the local directory. And even if there is no entry in the local directory, then the DNS, this whole mechanism of DNS has got some way to I would say, um, it has got some way or some mechanism to follow, right? So it will follow that mechanism. And for that, you need to understand the hierarchy of the DNS. So it would be important for us to understand the hierarchy of the DNS so that we can understand that how exactly this DNS is working out there, right?
Just one quick question. So, when you say local cache on the machine, is it again the host file or like the
No, no,
other
no,
other
no, no,
file?
no, no. It's kind of cache which is stored in RAM.
Okay, yeah. So if you don't define the DNS at all, right?
Mhm.
But the system will check for the local host file, right? With 127
That's right.
something
That's
interface.
right. That's right.
Okay, fine.
Hmm. And ideally you would not get entries in the host file, therefore you would not be able to access that application. So it is important to specify the DNS servers if you are really looking to access the internet, right? And you would see that from a system engineering point of view, in most cases you would see that if DNS server is not available, then internet would not be available on that machine. And a lot of times you would see that if there is an internet issue on the user machine, it is related to the DNS in most cases.
But so if you don't define the DNS completely, the system will consider 127.0.0.1
That's
as the
but
DNS server.
that would direct you towards your local host file, and host file doesn't contain all those names, right?
Yes, yes,
It's by default it is blank kind of thing, right? It doesn't contain any entries over there.
correct.
So if there are no entries, then it will not be able to get that name resolved against the IP, for that IP address, and therefore the request will get dropped.
Yep. Thank you, sir.
So remember that in today's world, the internet is heavily dependent over the DNS. If DNS goes down, the internet will go down. Trust me, seriously. It is not always good to say, or it is not always right statement that okay, the internet will go down only if the circuit is down or the connectivity connection is down. No, sometimes the connection will remain up. You have IP connectivity, but you will not be able to access your application. Why? Because DNS went down, right? So remember that internet access is all depending upon, obviously it has dependency over the IP connectivity. We all agree with that. It has dependency over the cables, right? The cable must be connected well, right? We all know about it. But at same time, we must make sure the DNS is also always up and running. Why? Because if DNS is down, then obviously you would always try to access your application using names. We don't put the IP address. Have you ever tried that? I don't think so that you ever tried to access the facebook.com using its IP address, right? Even it is not allowed. Let me tell you, frankly speaking, You can access the facebook.com using IP address, but they do not allow that. So even if you are trying to access the facebook.com using its name, its IP address, not name, it will not be accessible. Although you have the IP connectivity, but it will not be accessible. They will set up their application server in such a way so that if request is coming using an IP address, then they will not entertain that, right? So the request should be coming in using name only. And if you're trying to access the application using name, then you know then DNS must always be up and running, because DNS would help end user machines to resolve names into their responding or corresponding IP addresses, right? So DNS
What
is
is the
like,
sequence of
yes,
events? I mean, the system will first check the host file. If host file don't have the entry, then it will go for the DNS towards
exactly,
the server.
exactly, right. So local, that's from a local machine point of view, right? So if you have got some entries in the host, forget about host file, Sanjay. Why? Because host file is by default
No, I'm just wondering,
is
like,
null.
for some reason, right,
Yes.
DNS server is not able to resolve any of the IPs, right? Again, the system is go back and check the host file or like,
But point is that first it is going to check the host file.
correct, okay.
If there is no entry in the host file, or there is no response found in the host file, then only it will go to the DNS server, right?
Yeah.
And if DNS server is not available, or DNS server is not reachable, or maybe DNS server never responded back, so you are going nowhere then, right?
Correct, yeah.
You would not be able to access the application, the said application, whichever you are trying to access. So what I meant to say is that you are heavily dependent on the DNS servers, right? So now if we are heavily dependent over the DNS server, and just imagine that how many requests people are making in a second, right? Across the world, just imagine that how many internet users you have found, right? Or I mean, how many internet users you have. So you have got like billions of internet user, right? I would say billions. Now, if you have billions of internet user, and let's say most of them are using the Google 8.8.8 or maybe AWS A1.1.1 DNS server, they don't trust their own ISP, right? So they decided to use these Google DNS or maybe the Amazon DNS server, right? Now, if they are using those DNS servers, just imagine that how many requests these DNS servers are receiving in a second. Just imagine about it, that how many requests they will be receiving in a second. So you need some sort of scalability, right? You need scalability, you need kind of redundancy, you need some sort of high availability, right? So you have got all those requirements now at DNS level, right? Especially at DNS server level, right? So DNS is very critical part of, or I would say is a very critical component when it comes to the internet access. As I mentioned before, if DNS goes down, the entire internet connectivity may go down. And we all must be aware with that. We are heavily dependent over the DNS, right? In fact, if you want to check that, you can check on your machine as well. Like, for example, if I say CMD, I'm going to run that CMD as an administrator. I will pull it away. So that's CMD, and I could see IP config, right? So you can see that this is the default gateway for me, but it will not display you the DNS server, although it would be same for me, or maybe little different. I don't know, like I'll have to check that out, right? So if I say IP config / all, then it will give me the DNS server. So you know that I've configured this DNS server, right? 888 and 1111. So primary DNS server is 8.8.8, and this is my secondary DNS server. And also, I could look at the DNS cache as well, right? So the command for checking the DNS cache on your Windows machine, right? So the command would be so easy, ipconfig, right? And then display DNS, right? So it would display you the DNS cache here available on your machine. So you can see that these all are the DNS entries that I have in my local machine, local computer, local laptop's cache, right? Just keep going. Okay, all right. So I've got like link.vacom.com, right? So that's the IP address that we have got, right? And this is an IPv6 address, for example, .org. I don't know who accessed that, and this is for Zoom. So this is the IP address that we got in the response, right? And then this is also like Zoom, Vacom, and assets.msn.com or whatever, right? Akamai as .net. So you can see that, right? And IPv4 only or whatever, right? arpa.net, chat.eveng.net, and then we have got login microsoftonline.com. So the CNAME record. So basically, if you are accessing this name, then we are forwarded over to this name, right? And then we should have an IP address for this for that msidentity.com, right? So that's now again we have got the CNAME, so it will be forwarded over to that name now, AK private, and then again we have got the CNAME, and then it will go to that name, and finally you got this IPv6 address in response to that, right? So you can see that we have got IPv6 addresses, and my machine has got IPv6 address as well, so it can talk to the application servers using IPv6 address as well. But the function of the DNS is going to be same. All I wanted to show you is that your machine is going to have um, the local entries. So you can see that it has those local entries here, right, in its cache. So whenever the DNS resolution happens, your machine would keep that entry in its local cache. So next time when you access the same application, your machine do not require to send that request again and again. Although whenever a DNS response is received, the TTL is always there, time to live, right? And once TTL gets expired, the entry will also get expired from your local machine, local DNS cache, right? Because it is always important to specify the TTL, right? So that's that. Dinesh, you are asking about the CNAME and A name, right? So, I mean, it's about the DNS function, right? Or I would say it's about the DNS basics, right? So I will cover them. Just I will wait for some more time, and then I will cover this basics of the DNS, right? Do not worry about that. But all I wanted to explain here is that without DNS, it will not be possible for you to have the internet access, right? So whatever we are trying to access from our local machine, we could actually see that local machine is performing the DNS resolution before giving you the access to that application, right? So it is really important for us to understand this way. So whenever you hit a new domain from your browser, the first task would be to resolve the IP address against that name. Okay. So that's what's going to happen whenever you try to access an application using your browser, right? Now, let's talk about the DNS, domain name server or domain name system. When you talk about the domain name server or system, right? So let me do one thing. I will directly go to the DNS now because I don't want to talk about the big IP and proxy and so forth because you are already aware with that. So I will directly start with the basics of DNS, that how DNS is working, right? So evolution of DNS, I don't really have to talk about that. Why? Because I have already discussed with that, right? So because remembering IPs is so difficult as compared to memorizing the names, right? So that's where the evolution of DNS got started, because we thought of that it is easier for human being to keep names memorized, right, as compared to IP addresses, and that's where the names came into the picture. Now, obviously, you could do that using localhost file, but as I mentioned, that you have got millions of domains, and obviously you are also changing their IP addresses on regular basis. So it was like it could be done at operating system level, but yeah, as I mentioned, technically is very impractical, right? All right. Now, when we talk about the DNS hierarchy or this DNS protocol, so trust me that you have got a root domain first, right? So you have got a root domain, right? And then we have got here the second level domain or child, we can call them subdomains, right? So you call them subdomains or second level domain, it's the same thing, right? But first you have got the root domain. Look at there, this dot, that's a root domain, right? Now, when we talk about the root domain servers, right? Let me show you something here, root domain servers, right? So when I talk about the root domain servers, right, always remember that the root domain servers, basically, if you look at the INA, right, so that's the INA organization. So that would give you the list of all the root domain servers and managed by who, right? So these all are the root domain servers. A.roots-servers.net, B.root-servers.net. And you can see that who is managing them. So VeriSign, University of Southern California, Information Science Institute, right? Cogent Communication, University of Maryland, NASA, Internet System Consortium, right? And then US Department of Defense, US Army, NetNod, VeriSign, RAPE, right? So you can see these all are the list of root servers across the globe. And where are they hosted? In United States. All the root servers are hosted in United States, right? Now, point is that these all are the root servers, and there are fixed IP addresses, right, for all of these root servers, right? So there are 13 root servers. You can count them 3, and then obviously 3, 3, and 3 and 1. So in total, we have got 13 root servers, right? And these root servers are maintained by all these operators, right? You can see them. So that is also listed. Now, I just spoke about this this root server. You know what happens is, I will come to that point later, because if I start now explaining the DNS functionality, so you may get confused, right? And then we have got the subdomains like .com, .edu, right? .net, .org, .gov, right? If I go back, if I go back now to this list, right, and I must be having, let me just do one thing here. I'll give you one more link here for the subdomain. This is for subdomain, right? So you know that I just not subdomain. I have to look for the top level domains. Sorry, top these servers. I have to check the TLD servers list, right? Top level domains. This is the root server, which is fine. And root zone, forget about it. Yeah, this is the top level domain list. So these are the top level domain list, or I would call it TLDs, right? So these all are the top level domain list, right? And if I show you that list in more detail, probably you can go through this page, right? So these all are the like .com, right? That's the TLD. .org, right? Organization. .net, right? .int. So you can see them, right? And .academy, right? .accountants, Africa, so you can see them. These all are called top level domains, right? Ideally, you would see the original top level domains, and under original top level domains, you would see them like .com, .org, .net, .int, .edu, .gov, .mil. Mil is military for US military, right? .gov is for government. So these all are the, Now, if you go to .com right here, so .com, and then also you would see these are the second level domains, right, for .com based on. So you can see them, all these domains, the second level domains. But before that, we had the TLD. So point is that when it comes to the hierarchy of the DNS, right, whenever it comes to, like, whenever you talk about the DNS hierarchy, first root domain comes into the picture. Now, all root domains will have an entry for all of the TLDs, top level domains, and each TLD will have the entries for the subdomains. So you could see that here it is kind of hierarchical model, right? So what we are having here is that root domain, then root will have all the entries, like root will have database, and in its database, you would have all these top level domains. Then these TLDs, top level domains, would have entry for the subdomains, right? So first you had root domain, then we had TLD, right? Top level domain, and then we had subdomains, right? Like f5.com or cisco.com, right? Or maybe whatever, right? You can take any example. These all domains are known as subdomains, right? And within subdomain, you can also have like, you can see that again, you can have multiple level of subdomains, right? Like within f5.com, then you can have tag, and then within tag, then you can have different users like sourab.tag.f5.com or whatever is given, Fred, Steve, whatever, right? But this is how things are separated, right? So, or the DNS hierarchy is built. So you have got root servers and my Windows, like I'm not talking about the Windows operating system. I would say in this world, each operating system would have a list of the root servers. That okay. I mean, it already knows that who all are the root servers, right? So I'm not talking about the client operating systems, but especially I'm talking about the server operating systems. Like when you talk about the DNS servers, right? So for example, if you are hosting up your own Windows DNS server, the local, the private Windows DNS server, right? So on private Windows, internal Windows DNS server, what you can do is that you can create the local entries. And then if the DNS request comes to this DNS server for which it doesn't have any entry locally created, first it will always go to root. It will ask that, hey, okay, I need to get the IP address for this domain, right? Then root will provide, like, for example, if you were looking for an IP address of the google.com, then root would provide the IP address of the .com, right? Then it will go to .com, then .com would see, okay, this is for google.com. Then who is the authoritative server for google.com, right? So it will provide you an IP address of the google.com domain server then. And finally, you will go to f5.com or google.com, and that's how you would get the IP address of the google.com or f5.com, right? Point is that you are always going to follow this hierarchy. And remember that this is not something that you can immediately modify, right? It's a standard, right? That, okay, root, we have got the root servers for the DNS, and there are some organizations which are managing those root servers. Then we have got the top level domains, and we have got the organizations managing the top level domains, right? And then all top level domains would have an entry for the subdomains, like f5.com, cisco.com. So all the TLDs will have an entry for the subdomains, right? And the information will be stored at TLD level, right? When you go to TLD, top level domain, asking for that, hey, we need, we got a requirement for, let's say, we need an IP address of the f5.com or cisco.com or whatever, right? But this is how the DNS hierarchy works at global level, right? At global level. So if you have got an internal DNS server, you don't really have to, or you don't require to store all the entries locally on your DNS server. Although you can, like, you would like to create as many as entries you can, right? Why? Because the internet speed, for the end users also depends upon that how quickly the DNS resolution is happening. So as soon as, like if the DNS resolution was quick, then the internet speed will also be faster for the end user machines, right? Remember, the performance of the internet connectivity also depends upon the DNS resolution speed or DNS resolution, right? So as quickly as the DNS will get resolved, the names into an IP address, the end user would be able to connect with the application server, right? So the internet speed directly connects with the DNS resolution process, right? Or this DNS resolution. Point is that we have got the global hierarchy for the DNS, where we have got the root servers, then we have got the TLDs, and then TLDs would have the entries for the subdomains like f5.com, oracle.com, microsoft.com, whatever, right? And then F5 will be responsible to handle its DNS server. Cisco Oracle will be responsible for handle their own DNS servers, right? Now, sometimes you would see that you are a small company and you don't want to host your own DNS server, right? Right. So
So
what can be done in that case? So obviously the domain services can be hosted by the domain providers as well, like Cloudflare, right? That's one name. That Cloudflare is there, then AWS itself is there, and then we have got some other options like I gave you, just that example also. What was that? Let me just go back here in my cache. We had an entry for what? Just a moment. I just missed that name. I don't know how, but I just missed that name. I'll give it a sec. I will pick this up. Akamai, right? So even the Akamai is providing the same services here, right? So Akamai can also host the domain services for you, right? You can ask Akamai to create the entries, the DNS entries on your behalf, right? Same, you can ask the AWS Amazon. So you don't really have to, you don't always have to create your own internal DNS server, because if you are a small customer, a small company, then I don't think that you would be needing to do so, right? So that's that. Remember, this is the procedure, or this is the resolution process, right? The DNS resolution process, as I gave you an example, and now there is a graphical view, as I explained before. So let's say you are accessing this www.fi.com, right? So first, this local machine would check its local cache. If obviously the host file, the local host file, and then it will go to then it will check the local cache, and if there is no entry in its local cache, then it will go to the local DNS server. And this local DNS can be your modem or internal DNS server, right? Now this internal DNS server will check its cache. Local DNS server is going to check its cache. If not, then it will check its local binding tape, local bindings, or I would say local directory, if you created an entry for that. If not, then first it will go to like this local DNS server, right? So end user machine is not going to the root server directly. No, it can't go to root server directly. It will always go to its local DNS server. But then if local DNS server didn't have any, let's say it doesn't contain anything, in its it doesn't if it does not contain anything in its local database, then it will go to the root server. Now, root server, let's say you try to access fi.com. So root server will provide an IP address for the .com TLD, top level domain, right? And then it will go to the TLD that, hey, do you have any any information for f5.com, right? And yes, TLD should have that, right? So it will provide an IP address of the f5.com name server, which is the F5, which is a DNS server managed by the F5, right? And then finally, you will connect with the F5 DNS server. And that's how the F5 DNS server will provide an IP address against the F5 www.fi.com. And then local DNS will create an entry in its local cache and will provide the response back to the user machine. But here you can see that local DNS server has created an entry in its local cache, right? and then response was given back to the client machine. And now, since this client machine, this machine has got an IP address, right? And now it will try to connect with the web app server, right? Web application server. Okay. How does it look like now, guys? All of you.
Clear.
All right. Now, obviously, in DNS, we have got some sort of different terminologies as well. Not I mean, obviously, we covered couple of terminologies like what is root, what is TLD, and what is then subdomain, right? Then what is local DNS. So we covered these terminologies, but still we have a way to go, right? Because when it comes to creating entries on your DNS servers, we have got a couple of different entries like host A entry. In most cases, you would have host A or 4 times A. In most cases, you would have the entries for you would have these entries, right? In most cases. Right? So this is like just like host A entry is nothing, but it is kind of like for example, www.imedita.com, and this is the IP address 150.170.110.75. That's called host A entry for IPv4 addresses. So if you create an entry on your DNS server, you would have to create the host entry if you want to add an entry for name and IP and its corresponding IP address. That's host A entry, and 4 times A is applicable for IPv6, right? For IPv6. Guys, can you give me like 2 minutes, 3 minutes, and I'll be back then. So let's take a short break, and then we will continue further.
Sure.
Having a discussion around host A, 4 times A or CNAME. All right, guys, I have got one document for the Cloudflare. Like there is a Cloudflare document that I have got here, which I can probably use to explain you the names. Okay, so these are the most common types of DNS record that we use. So ideally, we need to focus on in maximum cases, we need to focus on A, 4 times A, and CNAME. These are the most common, I would say, most common entries that we create on the DNS server. So you were asking me, like someone asking me that what is the meaning of this A, host A record, right? So let me just explain that. Right. So if you look at here, A record, right? So basically it is a record which will hold IP address of the domain, or I would say IP address against kind of FQDN, IP address against fully qualified domain name, right? So for example, if you needed an IP address for hr.imedita.com, right? Or maybe it.imedita.com, right? So those entries will have to be created on your DNS server as a record and their IP addresses. If they have got the different IP, even though if they have this same IP addresses, still you can create their different entries, or you can also create the DNS entries like this *imedita.com. Like you can create a wildcard entry on your DNS servers. If you're creating wildcard entry on your DNS server, so if you send a request for hr.imedita.com, it.imedita.com, sorab.imedita.com, every time you're gonna get that IP address in the response from the DNS server, right? So a record will give you an IP address against your names, right? So those entries will have to be created on the DNS server. So when you create an entry or a record on your DNS server, which you are going to create, by the way, you will be creating those entries or those records on BIG-IP DNS as well, right? Because BIG-IP DNS is a DNS server. So you would be creating these records on your big IP DNS, and at that point of time, you would be understanding it in more details, right? But basically, it is a mapping of name and IP address. It is a mapping of name and IP address, and same goes with 4 times A. The only difference between A and 4 times A is the IPv4 and IPv6. A record is for IPv4 and 4 times A is for IPv6. That's the only difference. The CNAME is also one of the important record type that basically we create. This is also known as the canonical name, right? Canonical name. So ideally, we use this CNAME entry when we want that. Okay, if somebody, like, I have a requirement, right? What I want is that if someone is sending a request for it.imedita.com, right? They should get in response that you should go to, you know, like, I need to forward this user onto a different domain now. Let's say instead of it.imedita.com, now I want them to be forwarded over it.trainonic.com, right? Trainonic.com. And that's where this CNAME entry will take place, right? So canonical name is to forward one domain or subdomain to another domain, right? So if you are like, it's kind of forwarder, right? It's kind of forwarder that you use actually, right? Or kind of redirection. So on proxy servers, if I don't know how many of you have worked over the proxy servers, like especially the forward proxies, and on forward proxy you have got a feature called redirection, right? So sometimes you do the redirection, right? So this is a redirection at the DNS layer, right? Or at DNS level. So if you are trying to access some domain and you are sending a DNS request, in response, you would get another domain, and then you would generate another DNS request for that another domain. And you can keep forwarding your one domain to, to another domain. That is also something that that is doable, right? So CNAME is nothing but canonical name. It's just to forward one domain or subdomain to another one, right? The MX record is for email servers. Remember, the MX records will be created only if you have got some email servers, right? So if you have got internal email servers, then you would be creating the MX records for them, right? So that's that. And sometimes maybe you can create the name server records, the NS record, right? For services, you can create the service record, pointer record. So I'm not really expert into that, but all I have got for you is these three records, right? The A record, 4 times A, and CNAME, right? And these are the records that you create most of the time on your big IP DNS, or maybe on any DNS server, right? Even the MX record is also there because you would have some email servers. So you might have to create the MX records as well. But nowadays, since it's a time of Office 365, right? So you do not host those services locally, although you have an option, you can host that. But in most cases, you don't do that, right? So since you do not do that, right? So all right, so that's A record, 4 times A record, and then we have got the MX record, or whatever this CNAME record. So these are the records that we typically create on the DNS servers. There is nothing to do with these records on the client machine, right? And then, since these are the names, let me show you some more thing here, right? So server types. When we talk about the DNS servers, we also have got some different types of DNS servers, right? So root server, right? The root server, you have got the top level domain servers, and then you have got, like, apart from like root server and top level domain servers, you have got the authoritative server, right? So there are some terminologies when it comes to the DNS server types, and the only thing I would say is that you should be knowing um, um, their terminologies, right? Because understanding terminology is much more important, right? Because sometimes, like, when things are explained to you, and if you do not understand those terminologies well, then it will be difficult for you to grab the concept, right? So here, if you look at this whole process, right? So let's say you're trying to access some server, right? Application server like example.com, and example.com application is hosted on this server, right? You're trying to access that application using its name. Now, if you are trying to access that application using its name, so first it will send that query to its local DNS server, right? Local DNS. So you can call it LDNS or local DNS. And also remember, this is also known as DNS resolver. And also you can call it recursive resolver, right? You can also call it recursive resolver, right? When you go to your recursive resolver or DNS resolver or LDNS, so it's the same thing, local DNS. Then first it goes to your root server. And now, since I have already explained you that what are the root servers will provide you an IP address of the TLD. Then you will go to TLD, and TLD will give you an IP address of the authoritative server. Now, the DNS server who is hosting an entry for this example.com will be called authoritative server. Remember, the DNS server which is hosting an entry for your domain is called basically authoritative server, right? So this DNS server over here, right, is hosting an entry for the example.com, right, the domain, and that's why you will call it authoritative server, right? So in this process, you can see the resolver act as a middleman between the client and the DNS server. After receiving DNS query from the web client, a recursive resolver will either respond with the cached data or send request to the root name server, and then TLD, and then one last request will go to the authoritative name server, right? So that's that. An authoritative name server will provide you the DNS response containing the IP address of the requested domain, right? So that's what you would see then. I mean, that's what you would see here, right? So what are the name servers basically? So first of all, you have got the root servers. I don't really have to explain that. Then you have got the TLDs like .com, .net. These all are called TLDs, and TLDs will be responsible to all the TLDs are responsible to maintain. Let's make this session more interactive. Ask whenever you want and unmute yourself. Do not put questions in the chat. I am reading it today, but tomorrow, like probably I will not even take a look at.
Sure. Well, my question is, who manages the authoritative server?
Authoritative server is managed by, like, for example, if Google, right? If Google has their own DNS, local DNS server, right? Then authoritative server is managed by the, let's say, the Google itself.
Okay.
And maybe there are some other, just like take an example of the Cloudflare, right? So Cloudflare, or maybe the other name that I took just a while ago. I again forgot that. What was that? Come on.
Akamai.
Akamai, yeah.
Akamai.
These are also providers and can manage the authoritative server.
Okay, thank you.
Chaitanya, I mean, you should be able to unmute yourself, because I am not restricting anyone. Anyone can unmute themselves at any point of time, because I have not muted you manually, right? It's you who muted yourself. So you should be able to unmute yourself, each one of you. Okay. All right. So TLD, now you know that what are the meaning of the TLD, right? Top level domains. So the top level domains is handled by the INA, which is a branch of ICANN, and INA breaks up the 10 TLD, breaks up the TLD servers into two main groups: the generic top level domains and then country code top level domains, right? So these are the generic top level domains, TLDs, like .com, .org. And then country code top level domains are also there, like .jp for Japan, .in for India, .uk for United Kingdom, .us for United States, right? And then you have got the authoritative servers. Authoritative server, like basically is that server which hosts, or which has the A records created or CNAME record created in case if you are creating this, if you are having the CNAME entry created, right? So remember that resolver, the recursive resolver, the DNS resolver, right, will get a response from the TLD, that response will direct the resolver to the authoritative name server. So TLD must be having an entry that for this domain, this is an IP address of the authoritative server. So that entry has to be created on the TLD servers, right? And then authoritative name server will contain the information specific to that request, like google.com, and it can provide either CNAME record in the response or a record, right? It depends, like what sort of record it was containing, right? So you can also redirect one subdomain or domain to the other, right? And also you can provide, or you could provide, the IP address in response immediately. So basically, what I want you guys to understand here, that you should know that what is the DNS name resolution, what is the DNS resolution process. As I explained before, if I go back here, right? So you could see that how DNS resolution took place here, right? So you could look at here again. Whenever you try to access an application using your browser, the first thing it will do is to perform the name resolution. So first it will always check for its local host file, then its local cache. If not, then it will go to the local DNS. If local DNS has got an entry in its cache, it will provide response back immediately. If not, then first it will go to the root servers. Root will provide, and you know that how many root servers are there, right? And who is managing them. So then root server will provide an IP address of the TLD, top level domain server, and then TLD would be responsible to provide you an IP address of the authoritative server, or you can call them simply name servers, right? The authoritative servers are also known as the name server, right? So the TLD will provide that entry to the local DNS. So you could see, and this local DNS is also known as the recursive server, right? Or DNS recursive server, right? So you can also call it recursive server, this local DNS. It's working as a mediator, right, between the client and the root servers and TLDs and then authoritative server, right? It's working as a mediator over here, right? So finally, you must reach your authoritative server, or you call it name server, and then name server would be responsible to provide you the responses, right? Like the IP address against the requested domain, right? So you would have like either host A entry created on this name server or CNAME entry. If host A entry was created, then the IP address would be given in the DNS response. If there was CNAME entry created, then it will give the CNAME, and again the same process could be followed. Once CNAME entry is created, then this machine would send another DNS request for that CNAME then, right? If it has got the canonical name in the DNS response, then it will generate another DNS query for that CNAME, because at the end of the day, it has to connect with that, right? So that is also possible. Okay. So now some terminologies that we discussed today, like we know that what local DNS server is, or what is the DNS recursive server, right? What are the root servers? What are the TLDs? And then what are the subdomains, or, the kind of authoritative server or name servers, right? We also went through like some sort of DNS entries onto DNS server, like host A entry, CNAME entry, 4 times A entry. Those are the most common one. But apart from that, we saw that there was a pointer record, then exchange record, MX record, right, for the exchange servers. So we had those sort of entries that we could create on the DNS servers, right? The DNS resolution process, we have already gone through it, right? And of course, we also discussed about the different types of servers, right? As I mentioned before, the root servers, the TLDs, and then authoritative name server, right? So that
No. So just a quick question on this, on the CNAME part, right? So, like if you've created like a shortcut for any, so I see this as a shortcut, right? That maybe you have a big domain and then you are again kind of pointing it to like a shorter domain. So is it the TLD server that actually will kind of again do a lookup of the domain that it is pointing to, or will it send it to the system and the system again then request for the actual domain?
So if it belongs to the same domain, the CNAME, right?
Okay.
Then it already because your recursive server, right, or local DNS and DNS already had an IP address of the authoritative server in its cache, so it can directly go to that authoritative server. If it belongs to a different domain, then it will go back to TLD, right?
Okay.
And then we'll grab the IP address of the authority.
But the entire thing is it will not send the request back to the system, that now the system again needs to reinitiate a request for the actual domain.
I mean, it can bypass the root and TLD if the CNAME was part of the same domain.
Okay, so that means I can create a justsaay.com as a CNAME and point it towards let's say .org.
No, you can't. If it was, no, you can. But then process will be followed, like it will first go to the root and then TLD and then,
Okay, but so the question out here is, will the TLD server, when I've created a canonical name, itself kind of send out a query to the root server for the new TLD domain, or
it's a client?
Okay.
So
the system only will initiate it.
This system is going to create a DNS query, for example, .com. Will follow the root, then TLD, and then authoritative. But let's say on authoritative you create. Can you mute yourself? CNAME. Mute yourself. Just. A lot of echo I'm getting from your end. Either you need to change headphone, and if you are not wearing headphone, please wear the headphone. Else I will keep getting the echo from your end. Okay, so for this example.com, you could create a CNAME entry like mydomain.org, right? And that response will be given back to the client now. Now, client will generate another DNS request for that mydomain.com, right? You get my point? Or mydomain.org. And then it will come back to the DNS resolver. I hope that makes sense to you now.
Yes, absolutely. Yes. Thank you.
All right. So that's the basics of the DNS, that how things are happening. And one more thing that I would like to explain here, right? Or I would like to specify here, between your client machine, this is your client, and this is local DNS, right? You can also call it LDNS. The UDP is working there, right? But apart from that, like here in between these two, TCP is working there, okay? Same port, 53. Is that clear to all of you?
I just found out that DNS also uses TCP as well. So for good practice, you should use UDP and TCP.
That's what I specified here.
Oh,
That's what I specified. Between client and the local DNS, it will be UDP, right? And you should use UDP there, right? And between the servers, it will be using TCP. And that's a good
right. Okay, so on the firewall, you should allow both UDP and TCP.
Yes, that's right.
Okay.
If you have the local DNS internally, right? Because your local DNS can talk to the external DNSs using TCP. So you should allow both, right? But if you do not have the local DNS hosted in your environment, then obviously only the UDP will be used there. Only UDP will be used then. Because your client will send the UDP based requests.
Okay, makes sense. Thank you.
All right. So guys, this is it, right? From a DNS resolution process, or the key terminologies used here in DNS process, right? So we have already had enough now, like the big IP DNS can be used as authoritative DNS server. So you know that authoritative name server, right? What does that mean? So you can use big IP DNS, and also big IP DNS can be used as a local DNS. It's up to you, up to the requirements, that how basically we want it to use our big IP DNS to be used, right? So you can place your big IP DNS at the LDNS, as a LDNS server over here, and also it can be used as a authoritative named server. So you would see that in most cases, I mean, we are basically using in production environment, you would see that big IP DNS would be used as both, right? As both. So obviously, the main purpose of the big IP DNS is to make it as a authoritative name server. That's the main purpose, right? Because the main authoritative server would provide services for the internet users in most cases, not for the internal users. But for internal users, if you are leveraging your big IP DNS as a DNS server, then it will be called as a LDNS, local DNS, right? But ideally, we don't use that. We don't use big IP DNS like in production environment. Especially, I have worked for banking systems, right? So I have seen that we like I have not. I would not say I've seen. I would say that I have deployed the big IP DNSs in such a way that it's used as a authoritative or name server for the external for the internet users, but for internal users we are using some other solution for the DNS, right? Especially as a LDNS, we are not using F5 DNS servers for resolving the DNS queries for the lane users, for the local users, right? We have got some other solutions in the market. I have seen that mostly we are using. Let me show you. I just missed that name. I'll get you now.
Is it Infoblox?
Yeah, that's right, Infoblox. So nowadays, Infoblox is getting more and more popular, right? So I have seen that mostly banks are using Infoblox as a LDNS, local DNS, right? And the F5 big IP is being used as an authoritative server or as a name server for the external users, for the internet users. Because if you have got the internet users, let's say you have got a banking website, right? So for net banking, everyone is accessing that, right? All the bank users, or I would say all the account holders in that bank will be having access to the net banking, right? So you would have like millions of, let's say you have got millions of users, right? And you're expecting millions of DNS requests. You're expecting that, right? So obviously you would not be using info blocks in that case, but rather you would like to use the big IP, F5 big IP DNS to resolve their request coming through the internet, right? So that's where the big IP, big F5 big IP DNS would be working as an authoritative server. But for internal banking users, like we have an employees, right? We have got internal employees, right? So for internal employees, we will be using the info blocks as the DNS server. So that's what I have seen. I have been working on, right? But technically, the big IP DNS can also be used as LDNS.
Have you got a course for Infoblox as well?
Say again?
Have you got a course which
No.
covers Infoblox?
No. We don't.
Okay.
Yeah. Any questions, concerns, please, from anyone?
So when we compare this with LTM, so TMOS is hosted on the Linux operating system, correct?
That's right.
So this is the Bash operating system.
No, it's
So
not a
when we
Bash operating system.
Ubuntu,
It's a TMOS operating system, right?
no,
It's a
the
TMOS.
Linux one. The Linux one is
The
Bash.
Linux is a Linux. Bash is a script name. It's not an operating system name. Okay.
Okay.
Bash is a scripting language. Do you get it?
Okay.
Bash
Scripting
is
language.
not a operating system. Bash is a scripting language that is supported by the Linux machines.
Yes, correct. Now the question is like when we are troubleshooting LTM and GTM. So when we are doing a troubleshooting on the Bash mode, so it
Why?
has no relation with this TMOS related commands,
It
right? I mean
has.
model related commands.
See, point is that there are multiple ways to make the configurations and troubleshooting on your F5 loadable instance or big IPs, I would say. I mean, let's not talk about the LTM or GTM specifically. So we have got multiple options. One, use GUI, right, for troubleshooting, for making configuration. Use GUI method, right, and that's the most appropriate way as well, right? The second method is using TMOS commands. You have got a TMOS traffic management operating system, right? So in TMOS, you have got the TMOS commands, right? Just like Cisco iOS. Okay. The third way is to use the Linux commands in Bash mode. In Bash mode, you go back to Bash mode. which will take you into Linux, and then use the Linux command. So it's all up to you that how you want to make the configuration or you want to perform the troubleshooting. All are doing same. The only difference would be of commands, right? So during this training, I'm going to cover the GUI mode and TMOS, Traffic Management Operating System. I will not be covering Linux, the bash mode. Okay, sir?
Okay.
Yep. So basically, to work on big IP, you have got three different methods: GUI, CLI. In CLI, you have got two methods, the TMOS one and shell mode, which is Linux, basically, I would say, right? So TMOS is given to work on big IPs in CLI mode. And that's what we use even in production environment, right? I will not say that we don't use bash, we don't use Linux, we use, but at very few occasions.
When we use bash, so I mean, it is Linux based kind of commands, right?
That's what I'm saying.
Okay.
So when you create an object, you have got three methods to create that, right? GUI, then in CLI TMOS and bash mode or Linux, I would say. So when I say bash mode, is like bash is a scripting thing, right? So you can go to Linux and then you can execute those Linux commands and then you can get things going or you can get those objects created. So don't say that bash is an operating system, okay?
No,
Bash is a
that
scripting
is
tool.
by mistake I've said.
Linux is
It's
an
clear to
operating
me.
system.
Okay, fine. Thank you.
Final thing that I would discuss today is the diagram, right? Let's go back to the topology. So this is our topology that I'm going to work upon, right, throughout this training. And this is more than sufficient for us to learn the big IP DNS functionality. So you can see that there is a big IP DNS hosted here. And behind the big IP DNS, I have some Windows DNS servers. These are the Windows DNS servers, right? And then big IP DNS is connected through the internet. It's reachable through the internet so that we can use it as an authoritative server. And also we can use it as the LDNS. Okay. And the next thing that I have got here, that we have two data centers, two separate data centers. And in each data center, we have got one LTM hosted. And then your applications are hosted on LTM. And that's how you would perform the integration between GTM, which is DNS, and LTMs. Based on your configuration, this DNS would provide the DNS responses for the applications hosted in both data centers, right? So let's say there is a common application hosted in DC1 as well as in DC2. Now, big IP DNS would be responsible to provide the DNS responses to your internet users. Let's say there is a client PC, which is coming through the internet, and then it will send the DNS request to the big IP DNS. So it will provide an IP address of either DC1 or DC2. And that's what you need to learn, that which all different algorithms are supported by big IP DNS and in which scenarios you will be using which type of algorithms. Like you will be, by default, it's round robin, but then we can get it modified based on the requirements. Right, sir? So that's the topology.
So in practice, where would the big DNS be hosted? Physically, would it be in DCA or DC?
Both data centers.
And both
and
data
then
centers.
create a sync only group, right? So that when you create a sync only group, then it would, like whenever you create an entry on one DNS, the same entry would get created on the DNS hosted in another data center. So basically, due to the limited resources, I can't go ahead and configure two big IP DNSs, right? So I decided to keep just one DNS, and just imagine that it is in DC1 itself, right? Just imagine that this is in DC1 only. But ideally, you would have this big IP DNS available in both data centers.
So how would you get the two DNSs to be in sync? Because you can't have a keep alive between. Okay.
You must have. Dinesh, there are no data centers which are not interconnected if belongs to the same customer, right? Let's say I have a bank. I have got like DC and DRDC, right? So I must have backend connectivity between the data centers. Obviously, I must have that.
So there's a layer 2 between DNS1 and DNS2.
There must be a layer 3 connectivity between
layer 3,
DNS1 and DNS2.
Okay.
You don't require for creating a sync only group, you don't require layer 2 connectivity. Only you have got a requirement for IP connectivity.
Right. Okay. Can you go via the internet for layer 3 connectivity?
It's up to you how you want to provide the IP connectivity, via internet, via MPLS, via Metro Ethernet,
Okay.
whatever.
Okay, thank you.
Once the DNS resolution completes, there is no role of GTM. The traffic
Yes,
will be flowed
yes,
between the client and the LTM server. I
absolutely,
mean, mapping servers.
absolutely.
Okay.
So out here, what is going to serve as a local DNS? One more time, sorry.
I'm sorry. Say again.
Sir, इसमें like what device will behave as a LDNS out here?
In this topology, this
Yep.
router.
This router. Okay, the router. Okay, okay, got it.
This router can act as a local DNS. So you can configure that LDNS. And also you can make, like, for this client PC, you can directly configure this big IP DNS as a DNS server, and that will work as a LDNS thread.
Got it. Thank you.
So in the real production environment, usually GTM is used for the external users, right? I mean, the internet
That's
users.
right. That's right. Because that's where you get most number of, like, millions of DNS requests in second, right? That's where you need higher scalability, reliability, and also you need to protect your DNS server against the DDoS attacks. That's where you have got the requirement of those giant DNS servers.
Yeah, in case the user is internal, then in that case, maybe probably the DNS GTM can be used as the local DNS.
Yes, that's right.
Otherwise, there is no options. Yep. Thank you.
How do we access this lab, and is there a workbook?
There is, and we will share that information sooner.
Okay.
All right. So see you tomorrow then, right? And bye for now.
Okay, thank you, sir.
Okay, thank you, sir. Bye.
Thank you all. Bye.
Okay, thank you.
Thank you.
Thank you.
So yesterday we have covered some basics of the DNS, like how DNS resolution happens, and then some key terminologies that we use in DNS that we have covered so far, right? And today I'm gonna go ahead and get the access of this big IP DNS, and today we are going to set this up, right? We don't need to set up the DC big IPs. Why? I mean, those are LTMs, and I have already set them up, so I don't need to set them again. So in your topology, like, once you would have access to this topology, although you don't have that yet, but sooner you would have that access. So when I say sooner, which means that you will have to wait until Tuesday, because Monday is like kind of holiday, and until Tuesday you all will have access to the lab, and thereafter the big IP LTM will be configured by you, right? So the LTM will be configured by you, and I will give you the configuration of the LTM. I can give you like a kind of running config, and that you can follow to set up your LTM, right? But the DNS, right? So we're gonna configure it from scratch, right? So, and then also I will have a discussion around the ISP router configuration, the DC edge router configuration. So I will have a discussion around that. I can provide you the running config of DC edge routers as well as the ISP router and the customer edge router. Although, let me do one thing. I will go ahead and share the configuration of ISP first, right? So as you look at the diagram itself, the IP subnets are already listed there. So you should not be having any issues with that. You can take a look at the IP subnets which I have defined here on ISP. So like between ISP and the CE, the customer edge at down, left side down, right? So that's where we have been using 11.1.0/24 subnet, right? And .1 is always allocated to the ISP. And similarly, between ISP and the big IP DNS, we are using 12.1.0/24. And then between ISP and the DC one edge router, we are using 13.1.0/24, right? So these are the IP subnets, and then I'm using 14.1.0/24 between ISP and DC2 edge router, right? And then let me show you the real IP configuration for this ISP router, right? So this Ethernet 0x0, 0x1, 0x2, and 0x3. These are the IP addresses assigned on all these interfaces of this router. So this router has got, like this ISP router has got 4 interfaces, and you can see a complete list of all 4 interfaces. And then because we are using a public IP subnet at DC1 as well as DC2, you can see that. So in DC1, we have a public IP subnet allocated for this customer, which is 5550/24. And for DC2, we have got this IP subnet allocated 6660/24. And therefore, on ISP, I had to add static routes for those public IP subnets, right? So if you look at the static route 5550 going towards DC1 edge router, and for 6660, this is static route going towards the DC2 edge router, right? And then also we have one public IP subnet allocated for big IP DNS, right? Therefore, one static route goes towards like 770/24 that goes towards 12.1.1.2, which is an IP address of the big IP DNS. So these are the public IP addresses that we have allocated for the different, I would say, different sections of this topology, right? So these are the public IP subnets that we allocated, and therefore we had to add the static route, and that's what I have done here on this ISP router. And other than that, there is no other configuration, no NAT, nothing. So if you look at here, show IP NAT statistics, show IP NAT, like inside or whatever, right? So you want to see that. So show IP NAT translation, nothing is there, right? So this ISP is just a router which is allowing only the public IP addresses as per its routing table. So you can see that. So this ISP router is having only public IPs as part of its routing table. So that's how it has been designed. Then customer edge, if you look at the customer edge, right? So it has one public IP address that it got from the service provider. So this customer edge, if you look at the show IP interface brief, so E0x0, which contains an IP address, the public IP address, right? 11.1.2/24. And then 0x1 is having a private IP address. And then we added a static default route here, show IP route. So you can see that there is a static default route pointing towards the internet. And also, if you say show IP NAT statistics, so there is an inside interface, and then there is an outside interface, and then PAT has been configured, right? So if you look at here, show run pipesex and IP NAT. So PAT is running there, right? So you can see overload keyword has been used, and we are using interface IP address for doing PAT, right? And Ethernet 0x0 is configured with outside keyword, and whereas 0x1 is configured with inside keyword. You can see that. Other than that, there is no more configuration. That's it. So static default route, interface IPs, and then NAT was configured on this router. So basically NAT or PAT was configured on this customer edge router. Why? Because we wanted to provide the internet access for this client PC, right? And you know that private IPs are not routable over the internet, and that's the reason that I was forced to perform kind of netting on this edge router. Then these DC edge routers like DC1, DC2, right? So if you take an example of DC1 edge router here, right? So this DC1 edge router is obviously first IP addresses needs to be configured. So if you look at DC1, edge router. So Ethernet 0 by 1 should have a public IP address. So 0 by 1 is having a public IP address, yes. And 0 by 0 is having a private IP address, because internally I'm using 100.0/24 subnet between DC1 edge router and the big IP, right? So there is a big IP, there is a DC edge router. So on DC1 big IP, 1.1 interface is kind of like outside interface. So the IP subnet that we are using here is 192.168.100.0/24, and 100.1 is being used here on edge router. Ideally, it should be 100.2. I don't know how. Maybe 100.2 is being used on DC1 big IP, probably. But it should have been 100. Probably 100.254, right? I mean, as per the topology or as per my understanding, right? So okay, all right. I mean, looks like that it's not as I thought of, right? So, but currently this is the IP address configured here, right? And I can update this, right? So that should not be an issue. But for now, this is the IP address, and then it has got public IP address on public facing interface. And then it also has got a static default route pointing towards the internet. You can see that. And also it has a static route pointing towards the big IP for that public IP subnet that we have purchased for this DC, right? So you know that we purchased 5550/24 for this DC1 sub DC1, right? So what I want is that in case if DC1 edge router receives any packet for that public IP subnet, then it should forward those packets over to the big IP LTM, right? Because I'll be using this public IP subnet on this LTM, right? Same, like in similar manner, right? DC2 edge router is configured, right? And obviously the LTMs are also configured. I'm not displaying you the LTM configuration for now, right? Although, like if you want to take a look at this now, you could. Like it's not something which is out of my control. I can display it to you, but what I wanted is that since you are already aware that how do we set up the LTMs, so I was trying to ignore that configuration to display you, right? CTMSH, right? And then say list sys management IP. So that's 30.46. New session. Open. Okay. I'll just show you the IP addresses configured on different interfaces. So list sys VLAN. No, okay, no, that's the wrong command. List net. First, you can see the VLANs. So these two VLANs are there, external and internal, and then you could say list net. Let's say self IPs, right? So these are the self IPs which we have configured. So 100.254, you can see that. So it's 100.254 basically, right? I'll have to update this diagram a little, right? And then 20.1 is configured on the internal side of interface. So you can see that. So this is the IP configuration, and then also you could look at list net route, right? So this is the default route that it has got configured towards 100.1, which is the edge router. So it has a default route pointing towards the external network. That's that. And in similar way, in similar fashion, the DC2 big IP is configured. But apart from that, you could also look at list net, let's say, not net, let's say list LTM nodes, right? And then also you could look at the pool, right? And then also you could look at the virtual. So these are the whips, couple of whips that we have already created here. Like there is HTTP/VS1, there is HTTP/VS2. So these are the virtual servers that we have created on this LTM. Although we will be seeing them through the GUI, but for now, this is enough to understand from a configuration perspective of the big IPs at data centers. And these are LTMs, right? Although for now the license is expired, but we don't really have to worry about that. We will reinstall the licenses, right? For now, let's do one thing, this big IP DNS, because this big IP DNS is also pre-configured in this topology. What I'm going to do is I'm going to reset this now. To reset the big IP DNS, there is a wipe feature that is given in the EVENG, and you might also get a another button called reset. So the meaning of reset or wipe is all same, right? So I believe in your topology you would get reset, and in mine I get actually wipe, right? But it's the same thing. So the meaning of reset or wipe is all same. I have powered on this big IP DNS now, right? So on this big IP DNS, let this boot up, and I've taken the console access because first time you will have the console access of this big IP. So it will boot up now, and once it boots up, thereafter we will allocate the management IP, and then we would have the management access of this big IP, right? GUI access, and then we can make the other needed configuration. Even we can make the same configuration through the CLI. I will wait for 1 or 2 minutes, and if it doesn't come up, I'll have to reset it again. Probably I'll have to power it off, and then we'll power on it. No? Okay. I'll stop it.
So just one quick question, sir. So in the production environment, the LTM IPs what are configured here should be a public IPs, right? Because once the DNS resolution happens, the client will reach out to LTM via public IP, right?
Exactly. If you are accessing any application over the internet, any application, that would always be accessible through the public IP only. I'll give it some time here to boot up, and then we'll take it further. We are going to perform the first time, I would say, setup, right, on this big IP. So the default username and password. First at top, you can see that we are using big IP 14.1.2 version, right? And build is 0037. That's the current version that we are using on this big IP, right? And the username that we are going to use, the default username, right, which is root, and then the default password for the default is default, right, DEFAULT, right? That's what you have to put on. So when you put on your default password very first time, it will, it's a functionality of big IP. There is nothing to do with LTM or GTM, right? So we are setting up the big IP, and it's going to be same. It's going to be common across all the modules, whether you are deploying LTM or GTM or whatsoever, right? So the current password, right? So put the current password and then new password, right, that you wanted to put on here. So I'm typing the new password, and once you type in the new password, if it was match, right, then it will give you this message, right? I mean, if it was changed, then it will say that, hey, the password for the admin user ID has been changed to match the new password for the root user ID. So you need to read this, you need to read this statement a little, carefully, right? Because what it says is that the password for the admin user ID, ideally admin, we use it for GUI access, right? That's a default user ID for GUI access, graphical user interface. Whereas for CLI access, the root is the default user ID, right? Although we changed the password for root, but it says that, hey, the password for the admin user has been changed to match the new password for the root user ID. So whatever you set up the password for root user ID, the same password has been changed. The same password has been set for the admin user ID. I'm repeating my statement. Although we set the password for root, but the same password has been applied for the admin user ID as well. However, the password for admin user is marked as expired, right? So you can see that the password for the admin user is marked as expired, and you must change it now next time when you log in through the graphical user interface, right? So now we can see that, right? So thereafter, once you are done, so currently you're in bash mode, right? If you say pwd, you are inside config, right? And you are in bash mode, and this is called bash mode, right? Or I would say it's you are inside the Linux mode. So all you can execute here is the Linux commands, right? So pwd, ls, so whatever commands you know about the Linux, you all can execute those commands over here, right? In fact, you can also see some basic base configuration, like big IP base configuration, right? So all those configuration files are also available over here, right? And in case if needed, we can modify that, or if needed, we can edit that using the Linux itself. But I'm not going to do that over here, right? Now, from bash mode, you will have to move into the tmos mode. And to move into tmos mode, the command is tmsh. Once you put this command tmsh, now you are inside the tmos mode. So here, the command syntax will be different, right? Although it's a CLI again, right? But the command syntax would get changed because now you are inside tmos, and tmos is an operating system of the big IP, right? So you activate the module on top of the tmos, right? Now you are inside tmos, and in tmos you get command syntaxes starting with create, starting with delete, starting with modify, starting with list, or starting with show. So these are the initial keywords that you could use. So if you want to create something, then use create keyword, right? You want to delete something, then delete, use delete syntax. You want to modify something, then use modify keyword. This is how you do things, right? So those keywords are supported by the big IP. Thereafter, like once you move into tmos, thereafter you must set up your management IP, right? So for setting up the management IP, I do remember that on this big IP LTM1, I believe that we had IP address .46, right? So for this TNS, let's keep it 45, right? Because 45 is also available, right? So what I can do, like if you want to set up a new IP address on your management interface, right? Then the command would be like modify, right? Modify sys. First, you can look at the list, right? So you could say list sys management IP, right? So it has obtained an IP address from the DSCP. You can see that. So by default on big IPs, the management interface is pre-configured to obtain an IP address from the DSCP. So if you are running DSCP services in your network, then you would see that your big IP can obtain this IP address automatically from DHCP. Let's keep it from DHCP. I don't have any issues with that as well, right? And yeah, I mean, it must have also got the default gateway when it comes to the management interface, right? So if I say list sys management route, so it can display you the management route. So it has got this management route from DHCP. So since DHCP services were running in my infrastructure, and therefore this big IP DNS was able to obtain an IP address from the DHCP directly. So I don't have to, I mean, even for you in production environment, you don't have to allocate this IP address statically if DHCP services are running. However, I would recommend, like my recommendations, and not just mine, even if you are working with F5 professional services, right? They would also recommend same, right? You must allocate IP addresses on your management interface statically. You should not rely on DHCP because IP might get changed then in future, right? And you don't want to let that happen, right? So if you do not want to let DHCP change the IP address of your big IP, then make sure that you always allocate IP addresses statically, right? So that's better approach. But for now, let's keep it. But in case, let me show you one more thing here, because obviously it's part of the big IP. There is nothing to do with LTM or GTM. But if you are now trying to allocate IP address on your management interface statically, then make sure that you disable the DHCP services first for management interface, right? So first you will have to disable the DHCP services, and then only you can allocate IP address statically on your management interface of the big IP. Okay. But for now, that's the IP address, right? And using this IP address, basically, I can have the GUI access of this big IP from my browser, right? So if I hit, like, you must mention the HTTPS by your own. Ideally, you would see that on Cisco devices, right? Right. So if you look at the Cisco devices, you just have to put on the IP address in the browser, and then you would see that you would be redirected to the HTTPS automatically. But that doesn't happen in case of the big IP F5 devices, right? So there is no default redirection when you try to access the GUI, graphical user interface of the big IP. All you have to do is, like, you have to put the HTTPS as a prefix by your own manually. If you don't do that, then you would not be able to access the big IP. Just like if I open up a new tab and if I just put my IP address, nothing would happen. Ideally, in case it's not loading, right? So no redirection would happen. But when you put the HTTPS, then the page would get opened up, and there is a certificate error. Why? Because by default, big IP uses the self-signed certificate, and obviously your browser would not trust that certificate. Therefore, you would get this certificate error.